Hello,
Hi, Srini.
Aja.
How was your day?
Good.
Where has your teacher gone to? How up to?
No, this week no class.
Holiday, ah?
Yeah.
Okay. It's 40 mark. So I changed it to 11. Friday.
Isn't it 60 marks, Aja?
No. 60 mark is for 1.5 hours. We are only having 1
Oh,
hour.
oh. Okay,
Why
okay.
in
No,
having too
because
long?
real test 1.5
1 hour.
hour.
10 objective, 2 structure. Essay, I give you 2 out of 1. You do 1, I give you 2. A choice. Okay?
Wait, essay by right is supposed to do 2 in the exam, right?
Yep. They give you 3, you do 2.
Oh, no wonder you cut this.
I give you 2,
Oh,
you do
yeah.
2.
Oh, yeah. That means by right is 10 objective, 2 structure, 2
Objective
essay.
is 15, Objective is 15,
Oh, yeah. Okay. Yeah, it's 15 objective, 2 structure, 2 essay. Right, sir.
2 structure and then 2 essay. So I'm just following the format.
Sure, but would you advise me like in the exam, right? Do the structure and essay first, right?
You can just do briefly the objective first. Whatever do not leave it out.
Because like
Then
I don't want
structure
to
is
waste
the one
time
that
because
costs.
like each 1 mark, what?
Structure and essay is the one that contribute most of the mark. So you have to spend more time on that. Wisdom. Objective is only 1 mark. Structure.
No point wasting time on that.
No point wasting time. Structure and essay is the one that contribute a lot of mark. Okay, let us go to our checkpoint. Okay, number 6. Have you been able to do it? You find there's no choice. You don't practice it, you will lose out. Physics, you cannot study it by like other subjects.
Need to do exercise like maths.
Biology or chemistry. Physics is like maths. There's so many formulas.
Daily latihan.
Daily latihan. Just like your maths, you cannot study one. It's either you have it, you do it every day. Just like I did also the same thing. Every day I do it. That's why I'm good in maths. But physics I got phobia because the teacher is not helpful. They copy notes only.
Yeah, maths only number lah, no, not much to think.
Physics also for numbers also formula number.
No, but like need to think logic sense lah. This one only number only what. Yeah.
Maths also got logic You have to know which formula to apply. Okay. As I said, if they have not given you, so have you got number 6 done or not?
Number 6, yeah, got.
Can get the answer.
Can.
Oh, so I don't need to show you lah.
I just sure in case I did something wrong means just.
Okay. Usually the current will be. Sorry, I just close the door first. Usually, if they don't give you the current is usually given out by the cell. Like this one, given out by the cell. Given out by the cell. And then it will come down here. Okay. So even if you got it wrongly, as I say, you get negative value. That's all. So Kirchhoff's current law, that's the first step. Always Kirchhoff's current law. At junction here, Q or junction T, I and I1 go in, goes I2. Then you take a look, right? PQ, right? Choose the direction you want the current to flow. Easier to follow the general direction. Then you don't have too many negative. And sum of E, sum of V, E is 6. Then I pass through the 2 ohm, I2 pass through the 4 ohm, same direction. So add them up. Then replacing I from 1, right? So the I here. Okay, so that's what we get. And simplify it, divide by 2 and simplify it. That's what we get. And after that, use another loop. You can use the whole loop, or can use right? 2 more loops to choose as well. That loop, right? Choose anti-clockwise. So it's 6. EMF is 6. PD is there's a 2 ohm here. 2 ohm, the current I1 pass through it. And I2 pass through the 4 ohm. Okay, so simplify, divide by 2. You get 3 I1 that. And then you can see what to do with these two. Okay. The best is to times 10. No? Times this one 10. Then add the two equation. Okay, times 10. This becomes 30. This becomes minus 1. 1. And become 21. So 4 and 3 add together. You get 33, 23 I2. Then you can find your answer. Then from 3, the equation there, you can calculate your I1. And after calculate I1, use the equation. No? That equation to find your I.
Recording in progress.
Okay, that's how you do it.
Okay.
Good. Yeah, doing your homework. That's how you learn. How about this one?
The answer I got is 0.419.
Okay, let's go over anyway. The first one. Circuit diagram. The cell P, 3 volt, 2 ohm. Then cell Q. There's a cell Q, 2 volt, 3 ohm. If the resistance of the emitter is 5 ohm, what will be the emitter reading? As I said, current, usually the battery will give out the current, name it, right? And then you will come in here. This I2, this I, this I1. So first step is Kirchhoff's current law, right? Entering I1, I and I2 going in, coming out is I1. Then Kirchhoff's voltage law, right? Kirchhoff's voltage law, that's my short form, Kirchhoff's voltage law. Anti-clockwise. So it's 3 volt. EMF is 3 volt. Then your I times 2, I1 times 5. Then as always the case, we want two variable only. So we can replace the I because we are going to take another loop. That will be I1 and I2. Okay. So replacing I in 2. Got that equation. And we take another loop. As I say, you can take the whole loop if you want to. Okay. Okay, take this one clockwise. You got 2. And then I2 pass through the 3 ohm here. And I1 pass through the 5 ohm here. Then that equation there times 2 because you want to get rid of see the easiest one. No? This one is got I2, I1. So it times equation 4 times 2, we get 10, 6, and 4. Then equation 3 you times 3. Right? Then that will be 6. We'll get rid of each other. So you just add them up. Got an equation. Okay, your I1, is that the answer you get?
Yes, sir.
Good. And 2i from 2, equation 2 here, 2i equals to 3 minus that. So you got
So many equations.
0.452. And then from 1, you can calculate your I2. Yep, Is that what you get? Okay. Can or not? Okay.
Can lah.
Can already, so no need to do anymore lah. We go to potential divider. Potential divider also not much. Right? I won't bother about number 8 already, since you can refer to your note there.
What's the answer? Answer number 8.
Number 8. That's the answer.
Go back.
Right? You can roughly know which answer is which current is likely to be wrong. Right? I3. This is your I3. Right? I3 is likely to be wrong because it cannot send out this way. This one has to go inside there. Go inside there. Right? It cannot send out current because the source is the one that gives out the current. But it doesn't matter. As I say, you get a negative sign, then you know it's wrong direction. This direction is wrong direction. That's all. Okay.
Okay.
Checkpoint 15.3 is very easy lah. Can do or not? This one? Just find the current first. Right? Then current times each of the resistance, you get your answer. Can. Yep. Didn't do your homework.
Can? No, I did. Just maybe I did it wrongly.
Most of it are straightforward like this one. You don't need to use a formula. You can just usually it's best to, if they don't have a diagram, you just have your own diagram. Draw your own diagram so that you can picture what you do. Right? 2 resistors, 2 and 3, connected to in series a battery. That's a battery. EMF is 3 volt. And then this is 1 ohm. Calculate the potential difference across 2 ohm. So you can use the potential equation divider you want to. It's just 2. Then total is 1 plus 3 plus 2 times your EMF. That's all. If you don't want, you can calculate the current first. And then get your current. And 2 ohm. Right? I times R. I is 0.5. R is 2. You get that? Same. 3 ohm. You just times that. Then PD across the terminal is across these two, 3 and 5. Add them up. Okay. Just add 3 and 5. These two add together. No need to calculate like what I do. I just take the current total resistance, that's all. Okay?
Can.
This one a bit more challenging. 4 resistors are connected to a battery of EMF 12 volt with negligible internal resistance as shown. What is the potential difference between the point PQ? Okay. So find the current first. Current PQS in this group there. PQS. You got 12 volt. V is 12. Total EMF is 2 plus 4 is 6. Calculate that. Then you want your potential across PQ. It's just your current times your 2 volt, 2 ohm. 2 times 2 is 4. Then PX. PX is this one. So you have to find a current through here. Potential difference or EMF divided by total resistance 4 plus 4. We got 1.5. And Px is just across here, that resistance times the current. Then after that, you want to Q and X. Q is here, X is here. Yeah? You have no PQ, you have no PX. Just subtract. Right? Just subtract. PQ, you already know. PX, you already know. That must be the same point. You cannot take a cross here. Same reference point P. You calculate your QX. Subtract. Right? You must know which one is at a higher potential. Right? Potential across PX. This is 6. And then this is 2. This is 4. Across here is 4. So this is higher potential. So it depends on your choice. So negative means that this is higher, this is lower, that's all. Can? Yep. No problem.
C part again, sir.
This one across PX is 4 volt. Sorry, PX is 6 volt. Across
Yes.
here. Across PQ is here, 4 volt. Remember, they are all taking from the reference P. So it means that 6 volt is greater, X is higher potential. So I got negative because I choose PQ minus your PX. If I choose PX minus PQ, I got positive. Doesn't matter about negative sign. Just tell you that PX is higher potential. X is higher potential compared to Q. Can?
Wait, isn't it 6 minus 4 because X is highest?
Yeah, I can do that if you want to. Then you get positive.
Positive 2 lah. But still the same lah, right?
Still the same. We are not interested in, they didn't ask you which is at a higher potential.
Okay.
Okay, we haven't done this one yet. Let's complete our one.
So you think I'll go to school another 2 more weeks or will be in the house?
Next week is holiday, isn't it?
Yeah, I mean this week and next week, yeah. But the week after that, you think I'll go to school or not?
It's really up to you.
No. Like, will the government make us go to school or not? That's what I'm trying to say.
Oh, I think they will not allow you to go to school. It's likely it will be
because
another.
of cases.
You have to see the number of cases.
Today already 7,000.
You can see today is 7,000. So it depends on the number of cases. Still quite high. And then I think school is one of the source. The spread is from the source there. Anyway, we all expected already.
And a lot of children there, so they don't want to take risk.
We expected already that it will spread it because you got Hari Raya and then government also MC.
And some more, the English test, right, Mued, right? After 2 weeks from now, after that's supposed to have, but then pushed to October already. So I imagine the exam also might be pushed also.
So I don't know about our school. Government school are very harder because they are not ready. But for our private
A-level means they'll just do fast only. Online can finish the exam
we do online. Exam also online.
Can
okay. Why not?
I
think exam the government allow them to come back. So far okay lah. Because we are
no A-level means that means the exam means they do online, is it?
So far they are allowed to come back. But we are actually ready to do online. As I said, you just need a device to focus on you. And then we send you the paper. After that, you just make a printout for us. Just do a PDF copy, scan it, and then send it back to us. So cheating very minimum because we will be watching you through the Zoom. Okay, let's go to Shunt and Multiplier. Right? Moving coil meter, you don't need to know how it works. Right? That's why it's a moving coil, that's all. Pass the current, the needle will move. Has a low resistance. Right? It has a low resistance. And the maximum permissible current varies from a few
Teacher,
microamp. Yep.
we still haven't go to the potentiometer and Wheatstone bridge
Haven't
sub
yet because
topic,
we have to
right?
cover this
It's
one
still
first.
potential divider, right?
I know. We hopefully to
Okay,
cover
okay.
today. We have to do
Okay,
this
okay.
one first. Right? This is just application of your resistor in series and parallel. So moving coil meter, it has a low resistance. It can measure current very low. Depend on the type of galvanometer. It's just a few microampere to a few milliampere. So depend on type. So when we want to measure large current, right, you cannot allow large current to pass through. It will burn the coil of the galvanometer. So sometimes we want to measure large current or we want to measure large voltage. Right? Usually it is low risk. We say that it is low resistance. So low resistance means low current. So it means low potential across it. So if you want to measure large potential, we have to modify it. Right? Voltmeter and ammeter used in school are moving coil galvanometer as measuring instrument. Okay, so the voltmeter and the ammeter that we use galvanometer. Right? And you must know voltmeter is always across a resistor. Ammeter is in the loop. Right? Ammeter is in the loop or in series with this loop. Right? Okay, so usually when you convert to ammeter, they will give you the resistance of the galvanometer and they give you the maximum current you can measure. Right? IG. IG is the current through the galvanometer. IS, RG is the resistance of galvanometer, this one. Then they will tell you what current you want it to be measured. Right? That's the current you want to measure. So it cannot pass it through directly. It will spoil the coil there, it will burn the coil there. So you have to divert it to a shunt. Right? That's your shunt. Right? So I is this current that you want to measure. And then you pass through a shunt. So the current is I minus IG. Right? RS is the shunt. Right? The key principle that we use is that the potential difference across a galvanometer is the same as that across a shunt here. So shunt is connected across a galvanometer to convert it into an ammeter to measure large current. Right? So large current cannot go through. We go through and burn the coil. So we have to divert. We have a low resistance here to divert most of the current passing through here. The shunt has a resistance lower than that of the galvanometer and connected in parallel. So that shunt has a lower resistance compared to RG because low resistance, more current will pass through. Okay, let's do an example. Galvanometer gives a full scale deflection of 10 milliampere. That one, change it to ampere. Flows through it. How would you convert it to a ammeter capable of 3 ampere? You want to measure 3 ampere. Resistor galvanometer is 5 ohm. Okay, so now you want to find a shunt here, the resistor of the shunt here to divert the rest of the current. So solution, let the resistance of shunt be R. Current through the shunt, 3 minus that. Right, we are using Kirchhoff's current law, 2.99. Then we use the potential difference across here. Across the galvanometer is I times R. V equals I times R. I is 0.01 times 5. Right, so you got 0.05 volt. And that potential difference is the same as the potential difference across the shunt parallel. So for the shunt, resistance of shunt, right, we just take your V divided by I, right? R V divided by I. V is 0.5 volt. I is from here. That's your I. Right? Current through here. Okay. Anything not clear?
Okay.
Okay. To make into a voltmeter, remember voltmeter, it cannot measure small voltage. So you have to put another resistance here. Right? Same galvanometer can be converted into a voltmeter by connecting a multiplier in series. That's a multiplier. Multiplier is a resistor of high resistance. Right? This one, high resistance, connected in series. Just now it was parallel, this is in series. The current flowing through the galvanometer and multiplier is the same. That's the principle we are using. Because they are in series, the current flowing galvanometer and multiplier is the same. Okay, let's do an example. Right? You want a voltmeter to measure 20 volt, and then this galvanometer can only measure 10 milliampere. Right? Convert to ampere. Then we are required to find the resistance of this multiplier R. If the internal resistance of the, okay, let's finish this one and then start new Zoom. The internal resistance of galvanometer is 6 ohm. This one is 6 ohm. Okay, so you want to measure 20 volt across here. Current to the galvanometer and multiply is the same. That's the principle we are using. PD across the galvanometer across here. V I times R. Right? That's your I. Right? That's your R. 6 ohm. Got 0.06 volt. And got 0.06 volt. That's your V1. Now you can calculate your V2. Right? PD across the multiplier is 20. 20 across the whole thing minus your V1. Get 19.94. And resistor multiplier R is just V2 divided by I. Right? V2 I have calculated. I is this value. Inside there, I calculate. Can? Oops, sorry. Okay.
So go back again.
Yeah.
Some slides.
This one, no?
No, 15.14, sorry.
Yeah, that's your 15.14.
Okay, back to 15.15 just. Okay.
Okay, so that's your homework. Anything else you want to ask? If not, we will start a new Zoom. Give you 5 minutes break.
Not yet.
Okay, we'll try to finish your potential meter today.
Okay.
Okay, I'll stop here. You can start doing your homework if you want to. While you wait.
5 minutes break.
5 minutes break. You can do your homework if you want to.
Okay. Okay.